Hey guys, ScannerDanner here with my son Caleb behind the camera as usual. We are at my brother's shop, Danner's Automotive in Bethel Park, Pennsylvania. And today we're actually working on a truck from someone who found me through YouTube. He's obviously local to our area. We're in the Pittsburgh area. And found my brother's garage and brought it to him through my videos, which is pretty cool. The guy's name is Patrick. So Patrick, if you're watching, you may end up seeing your truck someday either on YouTube or on the Premium channel. Not sure where this is going yet, but our task today with this truck, which I don't even know year, I think it's a 2002 Chevy Silverado. 2003 Chevy Silverado, and I believe this was just purchased by this owner, and there was a lot of parts that were replaced. Complaint is a misfire, check engine light on, although from what I'm told from my brother, the customer's not feeling a misfire, but that's the codes that's setting. And I think it's had a fuel pump. I believe it was purchased not running, and it needed a fuel pump to get it running. Patrick, you have to forgive me if I'm getting this wrong. This is secondhand information, but pump was put in, it does run, but then it had misfire, and I think in an attempt maybe to fix the misfire codes, it got all new injectors, all new coils, plugs, wires, things like that. One of the things I noticed when I first started it, I hear an exhaust leak up front, and I believe we have some fuel trim faults in here too, and so that's a concern for me, having an exhaust leak way up there in front of the oxygen sensors. That doesn't help matters either. But let's start by pulling codes. We're gonna go for a test drive, see how it feels, go from there. All right, so when I was talking to my brother yesterday, he did mention to me that we had some fuel system rich fault codes, and those are concerning to me more so than the misfire, because in general, a misfire is not gonna cause rich condition faults. Even though you're sending unburned fuel into the exhaust, say with an ignition misfire, there's oxygen there too, and it will cause lean conditions. Misfires, in general, most of the time, will cause lean conditions with the oxygen sensor. You can have a misfire, say a mechanical problem with an intake valve that isn't operating properly, that you can have a rich condition. I've seen case studies that guys have done. I've never seen that myself, but it is possible. My point is this: I see a misfire, I see rich codes, I'm going after the rich codes first. Now, if those were lean codes with a misfire, I may attack the misfire first, as far as ignition, injection, things like that, vacuum leak. But this to me looks like possibly the rich condition is maybe causing the misfire. Also, the customer complaint is that he's not feeling the misfire, even though it's setting one. So that's weird, it just disappeared. As I was talking, my misfire code went away. All right, let's look at our fuel trim data, be next step. Well, no, you know what? Before we do that, I want to look at some freeze frame data. Just get some parameters here. When I was talking to my brother, I was asking him for this info, and you know, freeze frame data can sometimes be not helpful. And some of the data that he was given to me seemed to be that this is the case, because this is the fuel system rich bank 1 fault. And yeah, I mean, look at your fuel trims. Short-term trim is 1 and -1, long-term trim -3 and -6. Those are not in a range at all that would set a fault code. And so this is kind of what I'm talking about. You know, we can use freeze frame data, but sometimes it's just not all that helpful. It looks like, so engine speed 608. So we were at idle, 12% throttle. Yeah, we were definitely idling when this one set. In closed loop, warmed up engine, 190 degrees. So mass airflow at 7.4. I am concerned about the mass airflow sensor just going into this job. Let's see what the bank 2 rich fault shows. Yeah, again, these trims aren't really matching the code. There's positive 11 and 9 on the short terms, -6 and then 2 crazy. 1500 RPM. Really not helping me at all. Let's see the engine miss freeze frame data. And the trims are lean during the miss, which would kind of make more sense. Misfire and lean condition. But 11 on the long term, 16 on the long term, 5 on the short term, and 0. Let's see, this looks like this was under load because maps at 316, engine speed 2400, throttle angle 37%. Not really all that helpful, but it is something we don't want to forget about looking at. I'm like squinting at this screen, and I don't need to be. I brought my glasses. Yeah, right now we're running rich. So we have a bank 1 long term of 12 and a bank 2 long term of minus 18. Sorry, minus 12 and minus 18. Short terms are balanced. They're around 0. So I'm not liking that at all. Let me configure this. That's awfully high for a mass airflow grams per second reading. So this is is this a 6-liter engine?
Did you even mention it?
It showed it on the screen. I didn't mention it.
I wouldn't see that.
I know.
I can't see that.
I'm pretty sure it was.
Yes.
This is a 6-liter engine. Okay. So 6-liter engine, we should be about 6 grams per second at idle on the mass airflow, and we're reading 7.4. All right, this mass airflow grams per second, it looks a little bit high to me. So it's about 7.5 and bouncing around. This is a 6-liter engine, and so it should be about 6. And so that could be our rich condition right there. We have an over-reporting mass airflow sensor. One of the things about that number, though, I want to warn you guys about, because I hear a lot of feedback from you, is if you have an engine that is less than a 3-liter engine, this mass airflow compared to liter of the engine, we can no longer rely on as far as accuracy goes. And I learned that recently from a class I was in. The instructor's name was Eric Ziegler, and this was at the Super Saturday training event in Philadelphia. And he was talking about that number, and we all know that number. So, for example, a 5-liter engine at idle, you should have about 5 grams per second. 6-liter engine at idle, you should have about 6 grams per second, and so on. So this 7 point whatever we have on this 6-liter engine, to me, it looks high, right? It should be about 6. And I have seen engines, I think the one, Caleb, that we did the mass airflow sensor on the Hyundai or the Kia, it had higher numbers. It was like a 2-liter engine, and it had like 3.4 grams per second at idle. When we were done, those were good numbers. And so what Eric had taught us in this class is when we get down to 3-liter engines or less, that we can no longer use that number reliably. So you guys need to remember that. So a little tip for you guys. This does look like an over-reporting mass airflow to me. My next step, I want to raise my RPM and see what it does at a higher speed. Yeah, this is classic contaminated MAF, because as soon as I touch the throttle, my long-term numbers went positive, although my short terms are negative right now. That's odd. We're still really rich. It's like the memory's not there. I was thinking of a case study, dirty mass airflow on a Subaru. Some other cars I've seen where they'll go negative at idle and then positive at higher RPMs. Let's see where we are, 2,500. Still real negative. Not as bad though. So at 2,500, it's definitely better. Like almost normal trims at 2,800 on bank 1. Bank 2 is a little bit more rich. We're still minus 10. Feels real lumpy now, doesn't it? You feel that?
Mm-hmm.
Like I can feel a miss.
Yeah, 100%.
And now my grams per second numbers are at like 6.4.
So that's better, right?
Mm-hmm.
Yeah.
Long-term trim still minus 10. Long-term trim now on bank 1's minus 6. We were a lot different than that a few minutes ago. If I'm not filming, I'll tell you what I'm doing right now. I'm pulling the mass airflow out and taking a look at that, the wires on that. For you guys and for us, I'd like to prove it before I go under the hood. I don't know that that's a misfire. That's just more of a kind of a roughness feel. But fuel trims are now normalized. It feels pretty good, or it looks pretty good. Well, not anymore, -12. Because these were known to get the alcohol and fuel calibrations mixed up on these GMs. And misfire history on cylinder 5 is 22,000. Misfire history on cylinder A is 58,000.
Holy crap.
So 5 and 8 for sure. Still, again, I don't like that vacuum leak, that exhaust leak that we have up on this thing too. It does not help us when we're analyzing fuel trim data. I'm just looking to see if we have a alcohol percentage listed on here. That's really what I'm looking for at the moment. I don't see it. Nope. There's not a whole lot that'll make an engine run rich. Leaking fuel injectors, too high fuel pressure, leaking fuel pressure regulator, mass airflow problem, maybe a stuck open purge valve. Fuel tank pressure sensors at 0. Let's do a test here. See if I can do a bidirectional test on that. Purge controls the purge solenoid, closes the vent. Seal commands the purge solenoid to 0, keeps the vent closed. Okay. So I want to do this and watch these. What we should see is our tank pressure changing. Because it's sealed. And the fact that that's not changing is concerning to me. Let's go under the hood real quick, Caleb. I want to check, before we go take us for a test drive, I want to check his purge valve real quick. It's easy to check. Purge valve. Honestly, my main concern is it stuck open? And we can look at some fuel trim data and stuff too to help us, but it's not what I want to do initially here. With it electrically unplugged, we should have no vacuum pull here, and we do not. So my concern of a purge valve sticking open, causing our rich condition, and then changing the amount of trim data as it pulls the fuel out of the canister. So at times it'd be lean, at times it'd be rich. I'm no longer concerned about that. Does look like all new coils. I cannot tell if these injectors are new or not. Does not look like it. We can do an injector balance. We're gonna do that. All right, so I'm choosing this test next because it's one of the causes of a rich condition is leaking fuel injectors. And it's easy to do on this setup because I have a service port and I have the ability to bidirectionally control the fuel pump and fuel injectors with the scan tool. And this is literally a 2-minute test because of the setup on this. I have a gauge connected. What's that?
You want to go inside yet?
Not yet. I think we're going to go for a test drive.
Okay.
But I just kind of got lost in what we were doing. So these injectors do not look new to me.
No.
I mean, they could be maybe swapped out, I don't know. I'm just gonna do a real quick injector balance test.
Sure.
And so Caleb, to describe this to you, what we're gonna do is we're gonna run the fuel pump. It's gonna get us up to a specific rest pressure, and then we're gonna activate each injector for a precise amount of time through the scan tool. And then we're gonna watch our pressure drops. You ever seen this test done?
I think so.
All right, so injector balance, key is on already. So we hit continue. What we're gonna see is that gauge should, if we go injector 1, yeah, I need to exit out of here, and before I do this test, I need to start this and or run the pump. I'll start it. I need to purge the air out of this system. Like that. I don't know what the spec is on this car either. That seemed to build kind of slowly. But I'm not worried about low fuel pressure, not with rich codes. All right, so let's try this again. So we'll go injector balance. All right, hitting continue, doing injector 1 first. Nope, I need to make sure that I'm getting this right. So what's that, like 40, about 48?
48.
48 down to
30, 29, 30.
28, 29. Now we'll do the same thing for injector 2. We want the same starting point.
Yep.
That's a little bit higher. I'm going to give that a second, because we're about 48.
Yeah, it's about 49.
Ooh. We dropped to 28. Continue. Injector 3. We want these all to be the same. So what we're doing is we're firing the injectors for an exact interval.
Yep. Yeah, it's about the same.
Yep. A little bit under 28 there for a second. Kind of nice to have this done like an automated method. That one's lower. Uh-huh. That's 6. That's 20.
27.
27. We're going to do them one more time too. Number 8's a big concern for me. That pressure's a little bit lower to start on that one. That's about the same. Yeah.
Super low.
Yeah, and that's the one with the most misfires. All right, so here's what I'm gonna start this. Hold on, let me exit this mode. I'm gonna start this back up. We're gonna burn all the fuel that we just sprayed in the cylinders. There's a reason the system only lets me do it once without cycling the key and starting it up. So I'm gonna do that. Key off. Just letting it run for a second, blow all that fuel out that we just sprayed in the intake.
I can smell it.
Yeah. All right, now we're gonna do it again. I believe we're done, Caleb. I believe we have injector issues. I wanna look at this gauge a little bit better, so I wanna look more straight at it. So maybe if you get over my left shoulder and eyeball the gauge. All right, we're gonna do this again. Injector 1. Remember, both banks were rich, but bank 2 was worse. Whoa,
Holy crap.
that was down to like 25, right? Just above 25. We'll call it 25.
48.
That's a little bit lower starting point.
Yo.
These are different numbers. That's 2 PSI different right there. That was down to 23. We need to make sure our starting point's the same too. Yeah, we have injector issues here, people. So our first one was 25, 27, 26, right? Mm-hmm. We're gonna end up doing this again, and I'm gonna write them down. We'll go inside too.
Yes, we will.
$27, or no, 23.
Yep.
I said those numbers wrong. I meant 25, 20. I
thought you were talking about the first time around. I'll cut it.
Definitely have some flow issues here. Yep, there's 2 PSI difference on this. This is not, number 8 was the worst on our last go round. It wasn't as bad that time. How weird is that? Starting it up again. All right, we're gonna do this again. I'm not worried about the differences that we saw as far as what it drops to. This is a comparison from injector to injector. So some of you have questions on why is it different? I don't know. Air pockets, fuel temperature, don't know, don't care. What we want is the same pressure drop each time, okay? So first one, and I'm gonna wait till that drops to 48. We got a little bit of a bleed down issue going here, so hitting the button at 48, and that dropped down to just under 25, right? Not quite 24. I mean, my angle's off, and where I'm looking, what did it look like 24. To you? It was 24. All right, injector 2. We're gonna get this right at 48.
Yeah, that's a 48.
Just above, at least from my angle. I'm going from my angle, and I'm gonna hit it at the same point. So
24.
The last one was 24. That one dropped lower to, at least from my perspective. Again, my gauge angle's off. It was about half to 1 PSI different between 1 and 2, which is not bad. You want these identical though. Holding. Come on, baby, drop a little bit more for me. Still a little bit higher than where we were on the other ones.
A little bit, just a hair.
No.
A little bit higher.
If I'm seeing a 2 PSI difference, I'm not liking it. These should all be absolutely identical. See, we do have the lowest was 2 psi lower than that, wasn't it?
About.
We hit 23 on a couple, didn't we?
At least one of them, I think I saw.
That's
maybe.
too much difference. So part of our issue is an injector imbalance. This is number 8. That wasn't bad that time, but it's a stretch, man. Seriously.
Yeah.
Like it's not as bad as I thought. Initial one wasn't it? So now we're back to the math.
Oh my goodness.
Yes, it's cold.
Freeze.
We could go inside.
Yeah, let's do that.
We need to test drive this though.
Let's do that.
I want to do a quick visual inspection on this math.
Of course.
I don't like the injector balance results. That last one, to me, we had the maximum that I think you're allowed. I have written in my book no more than 1.5 psi difference between lowest to highest. But I have to be honest with you, that spec, I don't even like that. They should be identical, all of them. And we have almost a 2 psi difference on some of these injectors. That's going to absolutely be a contributing factor to our fuel trims being messed up. Probably would have helped to pull the air cleaner off. Oh, this thing's super contaminated. Not super, but let's see if I can show it to you. These ones are hard to show. Oh yeah, that's really dirty. See, now I'm thinking, do we test drive it and get some before numbers before I clean it? You're not going to be able to see that through the honeycomb, the resistors, especially that top one's pretty dirty. What I need is a spotlight. Do you have your light on you?
Yeah.
I don't know that you're going to be able to show this, Caleb. The backside, what I want you to see on the camera would be the resistor. So the little cylinder part on that guy right there. Same. There's one right there, and then there's one right there.
Okay.
So see if you can show that. That's the back side of it. So that's what you want them to look like. They're nice and clean. And the problem though with our camera is it's not going to show the front side. And this, especially this top left one, you can definitely see the blackness.
I can't show it.
I mean, my naked eye definitely can see it. And I don't want to take this screen out because I don't want to damage the screen. But we're gonna clean this just to see the improvement on the numbers. And I said we should test drive it and maybe do some VE type testing. I'm not doing that. I'm just cleaning it. We'll clean it, look at some trim data. Oh no, my bent brush is missing all of its bristles. Missing my brush. Well, you're in luck. We're going inside. You have, I need some MAF cleaner. And then I need, you know, the grease brushes, like little, like paintbrush for,
Yeah.
you got any of those that I can put a 90 degree on so I can scrub the front of this? Yes.
This thing I'm a freaking pack rat.
Yeah, can I bend it? You don't mind?
That's been sitting there for 10 years.
Sweet.
I need,
Some MAF cleaner, yeah. All right, you're not gonna be able to see well what I'm doing, but I'm spraying each of those resistors, those 3, and then I'm taking my brush, and then I'm gonna go on the back side of it. This would be where a light would help us. You know what? I'm gonna go get the light. There's no way you're gonna see what I'm doing. All right, come here, Caleb. We'll be able to see better. Just using this to gently brush the front side of those resistors that I really couldn't get to otherwise. Spraying them is never enough. One more. Spray it one more time from the front. Watch your camera for a second. There's still some crap on there. I wish I could show it to you. Okay. I like that. Let's go reinstall it, see where we're at, fuel trim wise, see if we had any improvement at all. I still think we have a little bit of an injector balance issue as well. We'll run that test maybe one more time after, since it's cooled off a little bit. One of the problems that you can have is when you have hot fuel, it tends to bubble and boil in the fuel rail as you're relieving pressure, and that can cause inaccurate readings with that test. So that is a variable when you're doing injector balance testing, because as you lower the pressure, you lower the boiling point. And so when you're doing that test and you're doing kind of a bleed down, the fuel can boil in the rail and then cause some bubbling, which then in turn causes pressure differences. I have to say, if this has any improvement on the negative trims, this will be the first GM that I've ever seen cause negative trims at idle from a dirty math. Seen it on other models, but never on a GM, not once. Okay, now before we start that, so we're gonna redo this injector balance. Okay, we're gonna do this one more time. I don't think I started the engine from the last one, but we'll be all right doing two. It's not letting me. It's gonna make me start it. Just under 25, just a hair under. That's like just under 24, almost 23 for injector 2. I need you to write this. Can you write something down for me, Dan? You got a pen, something to write down?
I smell gas.
I'm playing with gas.
It depends how much. Go ahead.
Hang on. All right, so injector 1, we'll call it 24.5.
Okay.
Injector 2, I want to call it 23.5.
Okay. Well, I got to sit here for
Yep.
6 more?
Yep.
I mean, I saw a snowflake out here.
It's freaking cold. That one's 23.
That's number 3?
Uh-huh.
23 even?
Mm-hmm. So I don't like the variation here at all. At all. You're not going to grab the gauge anymore, Caleb? That's
No room.
23 as well.
4?
Danner, come stand over here. Caleb, get back on the fuel pressure gauge.
Well, I already missed like 3 of them.
Well, we're going to do it again then.
Look, there they are. See? You don't need it.
He said we're doing them again, so. Hold up, man. I'm not ready.
23.
That's 5?
Yes. 23.
So this isn't going to start for crap.
Well, it will. I've been starting it each time. That's like 24 and a half for number 7. So we have a flow, there's a flow rate issue. It's not drastic, but it's definitely there. And
Did you look at the...
hold on, last one. And that was like
24.
24.
So when you look at the Misfire...
Number 8 had
like,
the most.
When 8 had the most?
Uh-huh.
And that wasn't as low as Or actually,
Right.
Okay, this
Yeah.
the
Not
lower is the better.
the lower would be more fuel flow.
More fuel.
Yeah. So I mean, these aren't drastic. So yeah. So
Oh man, I'm like, I can't.
so 23. Your max. Your max is. So we only have like. Well,
Pound
there's
and a
a
half, maybe,
yeah,
2
and that's
pounds.
like right on the borderline.
spec for
The
that?
spec that I've always used and was taught years ago is no more than 1.5 psi difference, lowest to highest.
Okay.
But what I've seen on good systems, they are identical across the board. We have a flow issue with these injectors.
Okay.
So I cleaned the MAF. It was dirty. Oh, good catch, brother. Good catch. I'm going to take
Good
this.
thing I brought my clipboard with me.
Yeah, exactly. I'm going to see how the trims look now that I cleaned the MAF. I was just telling Caleb.
Crap! Now you flooded it.
Yeah. No,
Are the coils new? They look new.
The coils look new. I don't think the injectors are. Maybe he put used injectors in it. I don't know. Last thing, we had a little mic change there with the camera. I was just mentioning I didn't like the injectors being a 1.5 pound difference, lowest to highest. It was weird that number 8 did have a really large pressure drop the first time we did it. And then after that, it did not. So that was weird. Number 8 was the one I was focused on the most because of the number of misfires. The mass airflow did look contaminated. I cleaned it. Let's see the result of our fuel trim numbers now. It's going to be a little bit flooded from our last balance test. We haven't started it yet. Again, we have an exhaust leak 2 up front, which is not a good thing when you're dealing with trim issues. So injectors I don't like, exhaust leak I don't like, but exhaust leak's going to make it go positive, not negative, and we're kind of more focused on the negative trims. I'm really curious to see. My long-term trim memory right now is -18 on both banks. I really want to see when this goes into closed loop what it does on the short term, and the fact that it really hasn't changed. I would expect to see these go very positive if we had corrected the rich condition based on the mass airflow alone, and I'm not seeing that. -14, -18. And I'll be honest with you guys, I think this thing needs injectors, or at least needs to have the injectors cleaned. Maybe an attempt to clean it. Yeah, still very negative. All right, we're gonna go test drive this. My MAF grams per second is about 6. I think maybe when we first looked at this and it was about 7.5, my RPM was higher and I wasn't really paying attention to that, and I should have been, because we're at like 580 now. You know, we'll be able to see in the edits what that RPM was, because the higher the RPM, obviously the higher your mass airflow grams per second is going to be. But we still have a rich condition going on here, and I don't like the flow rate of our fuel injectors. It's very possible that, you know, the one, did we have one drop to 25, Caleb, or were they all under 25?
No, we
had 1 or 2 that were at 25.
Yeah, about 25. I saw like at least 1.5 to 2.
And so I think that those are probably the only good ones based on the trim.
Yeah.
And the ones that were dropping lower were leaking fuel, essentially.
All right, are we driving now?
We are driving. Bank 1 long term just changed to 3%. Absolutely needs to fix that exhaust leak. I think my brother said there was a broken bolt on the manifold, so it's leaking right at the manifold. So what happens when you have an exhaust leak upstream of an oxygen sensor is when you have that negative exhaust pulse, you're actually pulling oxygen into the exhaust, creating a false lean condition from the exhaust leak. I know we're chasing a rich condition here, but that could explain our imbalance between bank 1 and bank 2. And bank 1 is the side that I hear the exhaust leak on, and bank 1 is less rich than bank 2. So we may have that being a factor as far as why we're seeing a difference to bank. But of course that can just be injectors as well. Doing a wide open throttle run real quick. Wanted to see full rich on these O2s. Certainly delayed. Pull over for a second here. dude. Bank 2 is minus 18. Pretty steady minus 18 too. All right, one more time. A first gear wide open throttle run. I don't like that. I don't like that at all. What is that sound? Was that a pop through? Was that behind me or in front of me?
It sounded like it was behind.
Oh, that's a clunk. I thought it was a pop through the intake, but it's like something in the drive line that was clunking.
Feels like it's right under me.
Yeah, that's.
Feel it right under me.
Yeah, that's not a. It sounded exactly like an intake backfire, but that's something in the drive line. I'm not a big fan of this mass airflow 0.2 millivolts at wide open. It's not good. We're gonna do this one more time. I need my throttle angle in here. All right, so first gear run. Where's my throttle angle at? Let's see that too. Sorry, Patrick. Did not mean to do that. We are not staying at wide open throttle, or we are not staying rich at wide open throttle like we should be. So that is a lack of fuel, not a rich condition. Opposite. Opposite. So all that did was complicate matters. There's a fuel delivery issue on this engine, which could put us back to the math. It could put us to the injectors too, if they're not firing properly as far as flow rate goes. Some that are maybe restricted, some that are leaking. I don't know. Let's look at some of these numbers. Yeah, I mean, frame 320 is where I went wide open, and that 0.2, that upstream. Let's see what bank 2 looks like. Yeah, it's like dropping lean. Stay here in the nice warm car.
Where are you going?
I'm grabbing my laptop so we can do a VE calculation. I mean, it had good power. You heard the tires squealing. Again, sorry Patrick, I wasn't trying to do that. I was just trying to get some wide open throttle numbers. These are new tires too, so probably took a couple miles off his tires. Oh no, battery's almost dead. All right, I was gonna start a desktop here, but I can't.
Okay.
I'll just have to let you see what I'm doing. All right, so it's a 6 liter. Intake air is 57. We'll go with those. 4726. Mass airflow of 241.69. And then 57 degrees for intake air. We are about 1,000 feet above sea level. The humidity of 30% is probably pretty close. Yeah, so the VE of 86%, that's just telling us our math is not the problem. And so our O2s that are dropping lean can be a fuel pressure problem. It is a new pump. I didn't check the specs as far as what our fuel pressure should be on this. I really think I want to put the gauge back on and do one more injector balance test. And I want to write it down this time, and I want to do some snap throttle fuel pressure measurements to make sure our pressure isn't dropping. And with the math looking good, VE number wise, airflow wise, we should be getting the fuel that we need based on the math. And the fact that these O2s between frame 330 right here, that's where we started. Let me pull my TPS in. Yeah, you can see where I went wide open throttle. Looks like maybe I let off a little bit because the tires were squealing. I didn't want to kill the customer's tires. You see during this run, like all in here, this should be full rich on these O2s, and it is not. And it is worse on bank 2 than it is on bank 1. It's kind of tough to make that call on the oxygen sensor, but it is not full rich. So when you see that, you're thinking mass airflow, low fuel pressure, injector issues, some other input, you know, map, and not a huge player on this one, the map, but it is involved, but the map numbers look okay. Usually when you see that, it's fuel pressure or mass airflow, and in this case, I believe we may have everything pointing back to an injectors themselves not flowing right. Okay, trims look better after it gets warm. -6. Don't feel a misfire when we were driving it. That exhaust leak got a lot quieter once it warms up, so not going to be a huge factor in our trims. I guess the guy's complaint is just that the light comes on and he's trying to fix it. I believe he's going to be putting a set of injectors in this to fix this car. So see, the bolt is missing in that location for that manifold, and we do hear some exhaust leaks on that side. This is bank 1. Is this drive-by-wire? Yes. So I want to do some snap throttle tests. I need to be able to see the gauge from inside the car. I just want to make sure our fuel pressure is not dropping off. Look how slow that builds too. Did you catch that? Yeah. Didn't like that. Just did a real quick visual on my fuel line, make sure it wasn't leaking. I don't want to see this pressure drop. That's what we want to see, an increase. That's good. Ooh, did not like that. Hold on, I'm gonna unplug the vacuum line on the regulator. Come out here real quick. When you're doing pressure checks, you saw in my last rev that it went up and then came down. Some of that's because of vacuum, and so what I like to do with vacuum regulators over here when I'm doing this test, if I can, if it's one like this, I like to take the regulator off or the vacuum hose off the regulator. As soon as I do that, you're going to see this pressure rise. So our pressure went up to like 57, 58. Here's me putting it back on, right? So now we're gonna leave that off. We're gonna do the same test. Now we shouldn't have a drop. And so what I've done is I've eliminated for your eye any change in pressure based off of that regulator is no longer gonna be a factor. I stated that wrong. Any change in vacuum, which affects the regulated pressure, is not going to be a factor for this test now, and I can watch my fuel pressure gauge. So watch it. We don't want to see a drop. A slight drop's okay, but we don't want to see a drop. That is a huge problem. That is our lean condition right there. Watch it again. That should not happen. Well, we dropped to 45 under load. This is supposed to be a new pump. Patrick, we have a fuel pump problem. We have a fuel delivery problem, as noted by our wide open throttle O2 test. But here's the thing. None of that, this fuel pressure drop, is gonna make our fuel trim numbers go negative. So I still believe he's gonna need some fuel injectors for that part of the job. I think we have some restricted / leaking fuel injectors, and we absolutely have a fuel pump delivery issue. I don't know what the problem is as far as that goes yet, but that's a problem. I'm gonna crawl underneath and see if the fuel filter's new or not. But something's not good with this pump. Danner, go on the other side.
There's something. When you rev this up, man, like it's bad.
Is it?
I mean, these are like exhaust leaks and hollowed converters, but it sounds like crap.
Watch this fuel pressure gauge, go on the other side. I took the vacuum line off the regulator to eliminate any changes in pressure. Sure. Watch this.
Dropping down to 45.
Yeah, from 58. So, and I noticed that on my test.
The new LS ones, do they still need 50 PSI for them to open?
No. Nope.
Not like the Poppet
Not like the Poppet style. Yep, good question. But so here's what I noticed on a test drive. It runs good.
Yeah.
I noticed that my oxygen sensors do not drop. I'm sorry, my oxygen sensors should be full rich at wide open. They're not. They're kind of fluctuating, and that's what put me, I'm like, wait a minute, something's off. And so we did a VE test looking at the mass airflow. I was worried about the MAF. I'm no longer worried about the MAF.
Okay.
But we have a fuel pressure that's dropping under load that's not related to the rich codes that we had. Now, did you mention lean codes ever on this?
Yeah, well, he said lean, but when I scanned it, I saw rich codes. The only thing I said lean was when I looked at freeze frame data on the Misfire at
I saw that
66 miles per hour. It's 2,800 RPM, whatever.
I saw that too. I saw that too. Positive 16 and 11, which is weird.
And at idle, it was totally opposite.
So it's very likely 65 miles an hour going down the road, pulling a load, that his pressure's dropping to a point where the thing's going to start to maybe even misfire and set lean codes, not rich codes. Now, the rich code part of this, I believe, is an injector flow issue. I don't like the numbers we had. They're too far off. We're right at maximum. So we have two separate issues. That dropping pressure gauge is not our rich codes.
Yeah.
Now,
what's it doing at idle now as far as like if...
Oh, I'm -6 on long term right now, -2.
Okay, so do you think the mass airflow being dirty could have done something with that?
I don't.
Well, that would be more lean, usually dirty.
But I have seen dirty mass airflow sensors cause rich conditions at idle speeds. Okay. I've not seen that on a GM, and when I first started this, I was 18 and 18, -18, and if that was the case, I would have wanted to see the short term go positive immediately after cleaning the MAF, and I did not see that. I think this is more temperature related than it is the cleaning of the MAF that did anything, I'm going to redo the injector balance test one more time and write everything down. I don't like the pressure drop that we have. You said this pump is new. He said the pump's new.
Knowing it needed a pump.
Did he put a fuel filter in it? I'm gonna do a quick eyeball. But multiple issues here.
Yeah.
But we've definitely identified a lean condition.
Sure.
It definitely looks like it's been replaced recently. Okay. You know what's nice about body lifts? That's awesome. What's nice about a body lift, which is this big old puck right here, that shouldn't be loose, by the way, is I can get right to my fuel pump connector right there. No problem at all. We're gonna do real quick power and ground check on that. I'm using my power probe again here, Caleb, because we're on a rusty frame, rusty vehicle, and I can go right to the battery to get an accurate ground, know for sure that I'm absolutely reading a good ground instead of relying on my meter. We use the power probe, a couple of adapters for the power probe so I can use it kind of like my multimeter. So I have an adapter on the end and then just a cable. And these were part of an accessory kit that you can buy for the power probe. And then we make sure up here, see, let's get rid of that beep. Yeah, 12.29. Okay, pretty corroded battery. Just want to make sure we're getting good numbers. All right. Going after the gray wire first. All right, 13.5, and then I want to make sure that that's not dropping. I'm comfortable with that. And then the ground, should be okay. Pump ground 0.4. That's a little bit high. All right, so I want to see that when I rev it. Okay, I don't mind 0.4. 0.4 is a little bit high, but not enough to cause an issue in my opinion. So he's either got a plugged up filter, I can't tell just by looking at it, or he's gonna need to put another pump in this. Let's get an amperage reading too. That's the float. I just went one pin down. That's your float level, 1.38 volts. And then this should be float ground, the orange. Yeah, that's the purple wire, by the way, which is your sending unit or your float. And that should be the float ground of 0.1 of a volt. And that's how I can tell when I'm doing pump circuits like this without a wiring diagram. That's how I can tell which one the pump ground is and which one the sending unit or float ground is. And it's simply based on the voltage level. And you see I moved it back to the pump ground. You see we're reading 0.4 for that pump ground. And again, like I said, that's a little bit high. I don't like that. I'd like to see 0.1, 0.2 maybe, but this is a higher amperage pump as well. These things run about 10 amps of current. And so that's not necessarily bad. Get you a real quick fuel pump current measurement. This ground's okay, Danner. Yeah. I'm gonna go
Body lifting all that, you never know.
Going over the gray wire, Caleb, which is the pump feed wire, okay? Whoops, I switched it to a 40 amp. Okay. Why is that not reading? What's wrong with my amp probe? There's nothing like fighting equipment failures. My amp clamp's messed up. Son of a... Seen this before with my Varus, and that's that the scope gets a little funky sometimes. You got to reboot it. Again. What the hell? Why is the tank pressure sensor not even plugged in? How was I getting tank pressure readings before? Why is my amp clamp not working, Caleb? I mean, I know I have amperage on this damn circuit. Something's broke. Something broke, Caleb.
I have one. You want one?
What, an amp clamp?
Yeah.
Yes, please. Yeah, so as far as where I'm at right now, I think he needs to rectify this drop in fuel pressure before he does anything else. I'm gonna secretly switch mine with yours.
I don't have anything good here.
Yeah, this one's working. Gotta fix my amp clamp now, Caleb. I'm on the pump ground wire. You can go on the feed or the ground, does not matter. Invert this. 10 milliseconds. Pause that. Zoom out. So we're averaging 7 to 8 amps of current. You know, the waveform looks decent. There is some up-down oscillations in that, but I'm not too concerned about that. I don't think. It could indicate a little bit of a mechanical binding issue. Not 100% sure on that. You know what? I want to redo this test. I'm going to drop this down to a 10 amp so we see it a little bit better. A little more detail. Pause that, zoom out. See what kind of RPM we're dealing with. My truck will draw, runs at about 9,000 RPM, which is a lot more than some, or I should say most. And it should be an 8-bar pump. We'll probably maybe use this low one. 1, 2, 3, 4, 5, 6, 7, 8. Back to 1. This might not be. Need to find a unique characteristic of this. It's kind of tough on a newer pump. Back to 1. That should be 8 bars right there. Let's get a time. And that's in 6.89 milliseconds. So my cursor placement here, I'm not really sure that I like it. Maybe like that better. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. I mean, it could be a 10-bar pump. It's just not common to see that. Okay, I think I like that little notch in that one. That little notch in that one. I believe that's 1 rotation. That's like freaking 12. What the hell? I'm having a real hard time with this one. Okay, let's redo this. And let's go volts DC. We'll do some math. We're going to AC couple this. And that's going to allow me to really zoom on this waveform. You guys want to know how to use the purpose of AC coupling on a scope? This is it right here. Just allowed me to zoom in on this better. Go from there to there, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll call that a 10-bar pump, and that thing is rotating at what? 8.36 milliseconds is 1 rotation, so 60,000 divided by 8.63. This pump's running at 6,952 RPM. Nothing, that's bad. I don't have a problem with that, but something is going on with it. I think mechanically, if you look at it, it just seems like it has some mechanical binding going on there to me. That could explain our low pressure issue. Giving this a ground right to the battery. So this is going to take the tool. I'm connected to ground. This should, so I dropped it down to 0.2. So from 0.4 to 0.2, 200 millivolt difference. See if we had any amperage change. Yeah, we definitely do. So I need to switch to the feed side though. Changing my ground current. So we're going from about 7 amps average when I ground this. Yeah, it's not changing really at all. I just didn't like the 0.4. So live we're 7.1 average, and now I'm reading 0.2 on my ground. And I take that away, 7 amps, so I'm okay with the 0.4. It just seemed a little bit high to me for the amperage we had. Totally fine with the pump ground. We have a pressure drop. Power and grounds are good. It leaves us to a mechanical issue, either inside the tank itself, something's wrong. Maybe he pieced the pump together, didn't put something together right. That's possible. Or 2, we have a plugged up inline filter, although my amperage is low and RPMs are in a range that suggests it's not a plugged filter, but that's it. That's the only other causes for this pressure drop. One more time, go back on the other side, Caleb. Ready? About 58. What'd that drop to? My head was below the dash.
No, it was around 45.
Use my foot this time.
45.
Should never see this. Never see this on a fuel pump, ever. 45, huge drop, huge drop. All right, so absolutely this tank's gotta come down, and or he's gonna change his fuel filter. My suspicion's based on current flow. It's not a plugged filter, because if anything, the amperage is a little bit lower than I expected to see. My truck runs about 10 amps and I run a 6-liter engine too, although mine's a 2009, this is 2003. I think something in the tank for sure. One more time, injector balance test we're gonna do, and we're gonna wrap it, we're done. All right, injector 1. Why am I reading a 51 PSI rail pressure now? Hang on. Could be temperature, and this is the hard part about temperature. It changes things like this. $51 to $30, right?
Mm-hmm.
51.
30.
It wasn't, I'm writing 30 for all 3 of those, but there was subtle differences.
Barely less than 30. That
Yeah.
looked like.
There was a couple that were like within half a PSI. That was like 29.
Looked like it to me.
Maybe 29 and a half.
$29.
$31. I might not have waited long enough. The pressure was maybe a little bit higher on that one. It's hard when you don't have the exact same starting pressure. That's 30. One more time. Plug our vacuum hose into our regulator before I forget. That won't make a difference on our balance test because there's no vacuum, but all right, cylinder 1, like different pressures every time. I think because this pump is
53 to like 30.
$29 on that one.
29 and a half.
That's cylinder 2. Here's cylinder 3.
30. $29. That's over 52.
No. 29.
29 for sure.
It's number 7. That was like 31, wasn't it?
30, yeah, 31.
Yeah, so we have an issue for sure still with the balance. About a 1.5 PSI. 30. Number 8 was okay though. So look at my numbers from both times doing them. So your highest or your most restricted, it only dropped to 31 on cylinder 7, and then the lowest, say 29.5 on cylinder 2. I'm sorry, lowest would be 29, wouldn't it? Hard, you know, hard to say which ones are restricted or leaking based on these numbers, but the fact that we have a 2 psi difference, I mean, maybe not quite. These 29s, were they above 29? Just a hair?
Maybe, I don't remember.
So still, I don't like these numbers. Don't like these numbers, and I think therein is going to lie your rich condition. You know, it's possible that 31's what we want to have, and the rest of these are all leaking some, which is causing slight rich conditions. You know, it's hard to say. Don't like those numbers. So what's the call? What do we do? Well, first of all, I would like to see this truck back after he fixes this fuel pressure issue. I'm going to tell him to drop the tank. I don't think it's a plug filter. He can try putting a filter in it, and I can instruct him on what to do on the fuel pressure test that we did. Powers and grounds are good back there. Absolutely something with what he did. But the problem with that is that's not going to fix our rich codes we have. I don't like the injector balance. We have at least 1.5 pounds difference, and that's the maximum, and they should be identical. So we have a flow issue with the injectors. Whether he's going to put a new set of injectors in this or try some, you know, in-tank cleaner is going to be up to him as well. 2 separate issues, I believe. I believe once he fixes that low pressure issue, that'll take care of his misfire he's complaining about under loads. I didn't see lean condition codes, although the customer states he did have them, and that would make sense that he does have lean condition faults based on the fuel pressure dropping under load. That also explains our wide open throttle O2s not going full rich, because we did not have enough fuel pressure. These ones are difficult when you have multiple problem cars, like multiple problem situations like this. It can definitely be difficult. And what we don't want to do is sell the customer a whole bunch of parts just in hopes we're going to fix things. No, we have solid evidence on where we're going. 2 separate issues, a low fuel issue and then an injector balance issue. I think between those 2, we fix that. You'll fix both of his problems, both the rich codes, the misfire code. He's also got a manifold bolt that's leaking too, and I hope we get to see this one back. I don't know that we will. This might be one because he's a do-it-yourselfer. We advise him, and then he does the repairs, and then he follows me, so you're going to see him comment on this video, which is pretty cool. So that may be the follow-up on this. I'm hoping, though, we get some after footage. We'll see. If not, guys, I hope you learned something. There was a lot of good testing methods in here. I know we definitely enjoyed ourselves. Not. But thank you so much for joining us. Make sure you like and subscribe and click the little bell icon so you guys get notifications on when I upload new videos. Guys, thank you so much. Caleb, thanks for being my cameraman, and we'll see you guys next time.